For centuries, we've stared at the stars wondering, what's out there? Well, it turns out the clues have been raining down on us all along. Some of the most fascinating planets in our galaxy weren't found by an astronomer peering through a telescope. They were found by an AI, years after the data was first collected. These planets were just sitting in our archives, hiding in plain sight, waiting for something that could finally see them. The biggest bottleneck in finding new planets isn't our telescopes, it's the absolutely overwhelming amount of data they produce. This is the story of how we're finally solving that problem, and how artificial intelligence is helping us find worlds we completely missed, changing our map of the galaxy forever. The universe is just filled with unknown worlds. We all know this. But what if I told you that hundreds of those worlds were already in our possession? Not as pictures, but as faint, almost imperceptible signals buried in years of data that humans had already combed through and set aside. These planets were lost. Not in the darkness of space, but in the noise of the data. Humans had missed them. A machine didn't. The cosmic fire hose. To get why, you first need to understand how we find most exoplanets. The go-to technique is called the transit method. Picture a distant star as a bright lamp. If a planet happens to pass in front of that lamp from our point of view, it blocks a tiny, tiny fraction of the light. For a little while, the star gets just a bit dimmer. Scientists study these dips in brightness, they call them light curves, to figure out if a planet is there. It's an incredibly effective method. Space telescopes like NASA's Kepler and its successor, TESS, have used it to find thousands of confirmed exoplanets. But here's the catch, the dip in brightness is often ridiculously small. For an Earth-sized planet orbiting a Sun-like star, the dip is about 1 part in 10,000. That's like trying to spot a gnat flying in front of a giant searchlight from miles away. And that's not even the hard part. The real challenge is the noise. Stars aren't perfect light bulbs. They flicker, they have star spots, and our own instruments can add glitches and errors. All of this creates a messy, noisy signal. A real planet transit can easily get lost in the noise, and a random bit of noise can easily be mistaken for a planet. These are called false positives, and they are the bane of every astronomer's existence. Now, multiply that problem by millions. Missions like Kepler and TESS don't just look at one star, they stare at hundreds of thousands of them at the same time, generating a mind-boggling amount of data. NASA's TESS mission, for example, has gathered data on millions of stars. Asking human astronomers to manually check every single light curve is like asking them to drink from a fire hose. There's simply too much data and not enough time. For years, this human limitation was the single biggest barrier to discovery. We were drowning in data, and we just knew that planets were slipping through the cracks. The ghost in the data, the first big public aha moment came in 2017. Researchers at Google and NASA tried something radical. What if they could train a machine learning model to do what a human does, but faster and with more stamina? What if they could teach an AI to spot the faint, hidden patterns of a planetary transit that human eyes might just be too tired to catch? They took their new AI and pointed it at data that had already been thoroughly picked over, the archives from the Kepler Space Telescope. They specifically looked at known multi-planet systems, places where astronomers had already found several worlds. The thinking was pretty simple. If you've already found a few planets, maybe there are more hiding in the noisy data that were too weak to confirm the first time around. The AI went to work, sifting through years of old observations. And it found something. In the data for a star called Kepler 90, a system already famous for having 7 planets, the AI flagged a weak, repeating signal that everyone had previously missed. It was the signal of an 8th planet. This new world, named Kepler 90I, was a rocky planet about 30% larger than Earth. Its discovery made the Kepler 90 system the first one found to have as many planets as our own solar system. This was the "wait, the planets were there all along" moment. It was a stunning confirmation. The AI hadn't just found a new planet, it had found a planet in data that had been sitting on servers for years. It proved there were lost worlds lurking in our own archives, just waiting for a new kind of mind to find them. The age of the AI astronomer had begun. A superhuman intern. So how does this actually work? It's tempting to imagine some kind of magical, sentient machine, but the reality is both simpler and, in a way, more profound. These are a form of deep learning called neural networks. In simple terms, you can think of one as a pattern recognition machine on steroids. Researchers train the AI by showing it tens of thousands of real, confirmed light curves from the Kepler mission. It learns what a genuine planet transit looks like, with all its subtle tells. Then, and this is crucial, they also train it on what isn't a planet. They feed it thousands of examples of those frustrating false positives. The signals from two stars orbiting each other, the flicker from star spots, the noise from the telescope's own electronics. The AI learns to tell the signal from the noise with superhuman accuracy. It's like a tireless intern that can examine millions of candidate signals without ever getting bored or fatigued. It doesn't replace the astronomers, it serves them, acting as an incredibly powerful filter. It sorts the cosmic haystack, finds all the potential needles, and hands them to the human experts for the final confirmation. This frees up astronomers to spend their time and brainpower on the most promising signals, dramatically speeding up the pace of discovery. And the incredible part is, this is no longer just a clever experiment. This technology has gone from a proof of concept to a frontline tool in the search for new worlds. Because the next generation of this AI is already here, and it's finding planets not by the handful, but by the hundreds. The Planet Validator building on those early successes, NASA developed its own specialized AI tool called ExoMiner. In its first big test on old Kepler data, it validated 301 new planets. More recently, an upgraded version called ExoMiner Plus was trained on data from both the Kepler and TESS missions. When ExoMiner first scanned the massive TESS data archive, it flagged an astonishing 7,000 potential planet candidates in one go. These aren't confirmed planets just yet, but they represent a best of list, hugely narrowing the search for human astronomers. And NASA isn't the only one in this game. A separate tool developed at the University of Warwick, called RAVEN, has also been combing through TESS data. In early 2026, researchers announced that Raven had analyzed data from over 2 million stars. From that, it validated 118 new planets, including 31 worlds that had never been identified before, and flagged over 2,000 other high-quality candidates for a closer look. These discoveries included some truly exotic worlds, ultra-short period planets that orbit their star in less than 24 hours, and rare planets found in the so-called Neptunian desert, a region close to a star where planets of that size aren't supposed to exist. This is the real power of AI. It's not just finding more planets, it's finding weirder planets, pushing the boundaries of our theories about how solar systems form. The future of discovery. We are standing at the dawn of a new era in astronomy. The universe was never really hiding these planets from us, we were just drowning in the data. AI has given us a life raft. What's next is even more exciting. These AI models, like ExoMiner and the tools developed for Raven, are often made open source. This means researchers all over the world can use them, improve them, and apply them to the ever-growing flood of data. Future missions, like the Nancy Grace Roman Space Telescope, are expected to find thousands of new exoplanets, generating data on a scale that would be simply impossible for humans to handle alone. AI won't just be helpful, it will be absolutely essential. These tools are also getting smarter. The next step is to train them not just to find planets, but to help figure out what they're like. By analyzing the subtle changes in starlight as it passes through a planet's atmosphere, AI can help us look for the chemical fingerprints of gases like water vapor, methane, or oxygen, the very building blocks of life as we know it. The story of the AI Planet Finder is about more than just technology. It's a fundamental shift in how we explore the cosmos. For thousands of years, discovery was limited by where we could point our eyes and telescopes. Now, for the first time, one of the biggest frontiers for discovery is the data we've already collected. These AI models are our new generation of explorers, charting unknown territories not in the darkness of space, but in the depths of our own archives. They are showing us that some of the galaxy's greatest secrets might already be in our possession, encoded as faint signals on a hard drive, just waiting for the right mind, or the right algorithm, to come along and read them. If AI can find entire worlds that were lost in the noise, it really makes you wonder, what else is sitting in our data right now, just waiting to be discovered? If you found that interesting and want to explore more about the cutting edge of science and technology, make sure you like this video and subscribe to the channel. Let me know in the comments what you think the next great AI discovery will be. Thanks for watching, and I'll see you in the next one.